Stem and leaf plots, again, represents data by separating each data value into two parts. You got your stems, you got your leaves. Usually it'll be something like, if you have a number like 52, the 5 is going to be your stem, 2 is going to be your leaf. It's just another way to represent stuff to try to make it easier to look at, rather than looking at some big long list of whatever the data is. Stem and leaf plot, this is the stem and leaf plot. You got your stems, you got your leaves. Again, it should always have, and none of these, my PowerPoint's not very good because it should always have a key, and that key will just pick a number. It might pick those two right there, and it'll say something like 9/0 equals 90. So it'll give you some kind of key to tell you that, because some of them that we do on something like this, instead of 9/0 equal 90, it might be 9.0, or it might be 0.90, or it could represent, who knows what the value is. Could represent 9,000 if they just left off a couple of zeros just to make it shorter so that you didn't have so much garbage to try to stick in there. Talked about this last time. Again, that's what that's showing. That number represents that. This is your list of data. The other thing we sort of talked about last time is a stem and leaf plot is sort of like a histogram. If I put bars around this, then it's turned sideways, it looks like a histogram. The difference in the from the histogram is in a histogram you can't tell what each piece of data was. In the stem and leaf plot you can still tell exactly, hey, Katie's score was this. You might not know each person's score, but you know all the scores. Something like this is helpful when, especially for like a teacher, when we get the state scores back. If they would put them in something like this, it'd be real helpful instead of just some big long list like they usually send to us. Constructing a stem and leaf plot. Just these 4 things. These are what you're going to do to construct a stem and leaf plot. Oops, 4 things. Missed one. Split each data up, however you're going to split it up. Arrange all possible stems vertically so that there are no missing stems. You can't go, just because there are no numbers in the 70s or something, you can't skip over the 7. You got to stick it in there still. Write each leaf to the right of the stem in order. Create a key. Different variations, we talked about the different variations last time. A split stem and leaf plot, sometimes you'll have a whole bunch of numbers in the whatever your stems are. So you might do something like have 1 twice, 2 twice, 3 twice. That's a split stem and leaf plot where you have each stem twice, and maybe you put 0 through 4 in one of them, or 0 through 5 in one of them, and 5 through 9 in the other one, or whatever, however you split it up, so that each set of leaves isn't so long. Back-to-back stem and leaf plot, a lot of times use back-to-back stem and leaf plot to compare 2 things, male and female. So you put males on one side, females on the other, and the stems go in the middle. Could be comparing 2 schools. National Trail compared to South or whatever, and put one school on one side, one school on the other. Some point throughout the year, we'll start taking symbols quizzes. something I like to do just to have like a starter. You'll have to know, maybe I'll throw a stem and leaf plot on there and say, what is this? So it'll be something where you're just doing these symbols and tell me what that symbol is, what this one is. Especially when we get into like into chapter 2, start of chapter 3, because there's all kinds of symbols and different kinds of graphs and plots and everything. Something I didn't say up here. If you got more than 20 stems, or we'll never have that many. If you're up to 10, 15 stems, that's too much. All right, your stem and leaf plot's going to be so big and long, it doesn't make any sense anymore. There's got to be a better way to do it then. That's too much to look at. Whole purpose of all these different kinds of graphs and plots and charts is to make things easier to look at, not make it any more difficult. Following are numbers of text messages sent last month by cellular phone users on one floor of a college dormitory. Display the data in a stem and leaf plot. So we're going to take this data, we're going to display it in a stem and leaf plot. Data entries go from the lowest one in there apparently is 78 and the highest one is 159. So what we're going to do is we're going to make, and I probably got this on here somewhere, but I'm going to go ahead and do it. We got our stems, we got our leaves, and all we're going to do is take the numbers, and it's probably, when you get a set of data like this, it's probably best to go through the data and line them up first. All right, so let's try to do that, and I'll do it over here to the side so we don't have to take up so much room. 78's right there. That's the lowest one, right? We just want to put it in some kind of order. So you guys help me out, and we'll call this first row, second row, third row, fourth row, so we can try to run through this pretty quickly. What's the next lowest after 78? 108. 105. First row? Is that the only one? 108 next. Where's it at?
Second row, third one in.
2 109s. 3.
There's one in the second row. And then 6 one in at the second row.
Is that all the 109s in? What's next? 112.
There's like 3 of those.
3.
2 on the first row, the last one. Yeah. And then the second one in the fourth row. Second row.
114's next. Oh, 113. Is there only one 113?
It's in the second row. It's in the first row.
114. So just one of those.
There's a 116. It's in the
then 118 after that, is that,
17.
there's a 17?
Yeah.
And then 2 18.
There's 3.
3.
3 118s?
And then a 19.
So let's see what we got. We're gonna quit marking at 116.
Yeah. 17 down to the right a little.
And then there's an 18 right beside it.
And
And
then
then the
there's
first
2 more on the
two.
very
First-
left.
We got the 19.
Very
The
left.
first and the second. There's another 19 at the end.
Very right, second row.
And then there's another 19 in the third row.
There's 3 119s.
Yes.
1, 2,
And then
3. We haven't missed anything yet, have we? Before we get too far. 121, is that next? Just one of those?
One of the third.
I think there's 2 of
One of the
121.
second.
Is that all the 121s? What's next? So just one of those or
2, yeah.
2 of them?
Cock row.
Oh, 3 of them. Never mind.
There's 3? Where's the third one at?
Second row, fourth end.
123s?
Yeah.
Just one?
Third row. And then there's a 124.
I see 2 of them.
2 124s?
Yeah. Both second row, third row.
One 125s?
Which way is
126 is next?
There's 3 of them, there's one in the fourth.
Right, there's the last one of the first row is a 126. Last one of the first row.
So 3 of them?
Yeah.
Yeah.
There's 3 of them.
That one, that one, that one.
There's 4. There's 4.
There's one, there's one in the second.
5.
There's another one?
Right, diagonal, there.
First
First
row.
row.
Did I get them all? Did I mark them all out? 127s?
No, 129.
129s next?
2 of them. First row of the last row. 32 maybe? 130.
There's a 130? Just one of those?
Yeah. There's 2, 133.
133, 133. There's one 134. Where's it at?
Right, third row.
And then 130.
139's next. We don't have anything in between those. 2 of those. Before we go on to 140, we're looking through there, nothing but 40s and 50s left, right? Make sure we haven't missed anything. 140's next. How many of those? Just one.
42.
Just
44. 45. 47.
45, 44, 42. So we got, there's another 45.
47. 48. 55. 59.
Is that all of them? Nothing's left unmarked, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. say there were supposed to be 50 of them.
Mr. Result,
Yes.
do you have Bryce on this?
He's not here today.
All right, thank you, sir.
Uh-huh. 1, 2, 3, 4, 5. There's 50 of them. So just to make sure that we have them all. Now when we do our stem and leaf, we'll start at 7 probably. That's our first stem. We can't just skip all the rest of these stems, so we're gonna go 7, 8, 9, even though there are no 80s or 90s. Then the second part of your stem, this in the description that I gave on one of the other slides, it says, you know, cut it off at the first number. Well, you're probably not gonna cut it off at the first number, you're gonna cut off 2 numbers. So your stem will be 10, 11, 12. I'm running out of space there. Not gonna be a very good stem and leaf, shouldn't split it up like this. 13, 14, 15. Then when you put in your numbers, you're gonna put 8 right here. That's the only one in the 70 stem. Then we just go down through here and we're gonna put in all of these, the ones that are in the 10 stem. That's right there. So we put in, we skipped 8, skipped to 9, go down to 10. We got 5, 8, 9, 9, 9. Notice, key part here, and I probably won't do this whole stem and leaf plot, but I wanted to make sure I got to at least some of this. No commas. Don't put commas in between them, they're unneeded. Alright? So, our key is going to tell us, when we make a key for this, we're going to have a key and it's going to say something like 10/8 means or equals 108. So we don't need commas in between all those numbers. Then we go to those and we got 2, 2, 2, 3, 4, 6, 7, 3 8s, 3 9. And then we could keep on going on. I'm not going to finish it all out. But that's your stem and leaf. Again, make sure you have a key. Probably needs a title too. These would be, what did it say, text? Is that what it was talking about? Text sent? Stem and leaves are pretty easy, nothing real hard about them. The hardest part about stem and leaf is just the work that they take to put them in order. And I think the next slide, or one of the slides coming up, shows an unordered stem and leaf. Don't ever do an unordered stem and leaf for me, because that's ridiculous. It doesn't do any good for anything. That would mean instead of going through and putting all these not in order, you would have just put like the 5 and the 15, the 9, the 4, and they would have been all out of order. That doesn't really help anything. Because here at least, when they're in order, we can tell on the, this is 112 to 119, we can tell how many 119s there are. So you can tell a lot of information from it if it's in order. If you don't have any order to it, all it does is sort of show you where the most of them are. So that's what the stem and leaf plot would have looked like if I would have finished it. Notice you can sort of tell, where most of them fall at. This one is unordered. This one is ordered. They both sort of look the same, but on this one you can tell more stuff. If I ask you which number occurs the most, you could go into that one and pick it out. If I ask you which number's exactly in the middle, you go into the order and pick it out. if I ask you which number's in the middle, it's not gonna work out over here because they're not in order and you can't tell for sure. Alright? Outliers. Did we have any outliers on that?
78.
78 problem. And we're gonna figure out a way later on in the year, we'll figure out a way to tell for sure if that number is an outlier. Alright, there's a certain formula that tells you, is this an outlier or is it just a low score? So outliers, numbers that don't actually fit with the rest of the data, 78 is probably an outlier here. And if we put Sydney's on here, if she was part of this, she would probably been an outlier, right? Folks tell you that. Stay off your phone. They don't really. They're just happy that you're occupied and getting your name on. A dot plot. Stem and leaf plots and dot plots are probably the two that I would use the most. But a lot of probability and statistical stuff are given in other forms. A lot of times you'll see a dot plot, but it won't have dots. Right? It might be something that you might have learned in the past, like a picture graph, where instead of dots here, maybe they put little smiley faces or something, some kind of picture in there just to catch your eyes. On a dot plot, all you're going to have each time on a dot plot, you probably have some kind of title for your dot plot, something explaining this down here, whatever it is, number of shoes, who knows, doesn't matter, whatever it is. You have a number line, don't draw a whole number line, alright? I had to explain this to my 7th grade son the other day. He started to draw a number line, and every time somebody draws a number line, they want to put what right in the middle? 0. If we don't need 0, don't put it on there. Draw the part of the number line you actually need. Here we only need it from 20 to 45. That's way too long anyway. We don't want to do any more than we absolutely have to. Alright? We put all those numbers on the number line, and you just put a dot. So for 21, we put a dot right here. Then we go to 25, we put a dot above it. Then another 25, put a dot above it. 26, and you just put a dot. A lot of times, instead of doing a dot plot, I'll do same thing, except I'll put X's. Maybe that one's got 3 above it. That one's got 2, 1. Doesn't matter what you use, it's still giving you the same idea. I use X's just because the X is a little easier to draw sometimes than a dot. So if we use those same numbers and we're going to make a dot plot for that, all we're going to do, we're going to put from 78 to 159. We'll get rid of Sydney's, we're not putting that on there. 78 to 159, we put them all on a number line. And you might even leave off a lot of times, because if I go from 78 to 159, that's a whole lot of numbers. Alright? So on this, I might even put a little asterisk out here somewhere and put 78 just to show, hey, that's probably an outlier. It's way out there. That way we can start at 105 instead of 78. Even this is gonna be too many numbers, and I'm not gonna do the whole thing. So that means I'd have to put 50-some numbers on here. All we do is put a dot above 105, dot above 108, dot above 109, another dot above 109, another dot above 109, 110, 11, 12, three of those, 113. And you'll notice if we were to do this all, when we get finished, you have sort of what could be turned into a histogram anyway. It's just showing how much is in each of those numbers. So it's sort of showing the same thing, still just like a histogram, except now we know that that number right there was exactly 105 and not in some class. So they actually went, and you'll notice this number out here, they actually started way down at 70. That's way too long. I wouldn't ask you to do a problem that is that long. But if you look at it right here, we could look right at this number. Which number appeared the most in our 126? So we know that that one appeared the most. You could actually go through here and count and figure out which number was exactly in the middle. You could figure that, which is, anybody remember what that's called when it's right in the middle? Median. One that occurs the most is the mode. Mean is the one where you add them all up and divide by how many of there are. Down here they say 78 is unusual. Again, you probably wouldn't put it on your dot plot. Pie chart. Pie chart's a little tougher. Everybody knows what a pie chart is, but nobody knows how to use it. Pie chart is a circle that's divided into sectors that represent certain categories. Notice, what we've been doing until now was quantitative. Pie charts are qualitative. Pie charts deal with some kind of quality. Maybe it's splitting up freshmen, sophomores, juniors, and seniors. Maybe it's splitting up different towns or whatever it happens to be. It uses central angles. Don't forget, a circle is always 360 degrees. You know, everybody remembers central angles from geometry when you had me in geometry, right? Central angle, if I draw a circle, central angle is that angle right there. Angle that has its vertex at the center point of the circle. And when we have a central angle, we know that this angle and the arc that it cuts off, the part of the circle it cuts off, always the same. So if this angle is 40 degrees, that angle is 40 degrees, then that arc has to be 40 degrees. So we could find the distance on the edge of the circle or the angle depending on which is easier. I'm not going to expect you, we could get out our protractors up here and I could give you a piece of string maybe and you could measure around the edge of a circle to get distances and stuff. We're probably not going to go that precise. What I do want you to be able to do is, if we have something, if we're doing a pie chart and you know that there's 100 total people that we surveyed or whatever, and 50 of them said one thing, 25 said something else, 10 said something else, another 10 said something else, and then 5 said something else, and we're trying to split this up that way. You should be able to do this. It doesn't have to be exact or real precise, but you should be able to do it within reason. And when I look at this one, what you're going to do a lot of the times is just look at that, and what do you know about that 50 out of the 100? It's half of it, so we'll call this A. This is B, this is C, D, E, F. So we know the A is going to be that whole half of the circle right there. Then what are we going to do next after that? 25 out of 100 is what? That's not supposed to be A, that's supposed to be B. Heck, don't you tell me that's messed up. How are we going to do the 25? It's like a quarter of the circle, right? So what kind of angle is 25% of a circle? A right angle, 90 degrees. So we put C right there. Then with these last ones, we got this part down here, this sector down here to split up yet. How do you think you're going to split it up? What do you know about these two? Same, and this one is what in relationship to those two? About half of each one of those, right? So you just look at this and you say, okay, I got two that are going to be basically the same, and then one that's going to be about half of that. And just make it that way. That's D, that's E, that's F, whatever those categories are. And that's going to be close enough for me, right? I'm not going to ask you to be real precise. Numbers of earned degrees conferred in thousands in 2007 are shown in the table. Use a pie chart to organize the data. What's the first thing you're going to have to do in this when we have these numbers right here? Add them up. You got to get that total. All right, you're going to have to get that total. Let's see, that's 1,253, 1,857, 1,857 plus 150. What's that? 1,857 plus 150, 70. Sort of strange. That's a year, right? And that's 2007. So we want to take that 2007, and probably what you want to do is change each one of these, or divide each one of these by that total to get a percent. When you get that percent, then that'll sort of help you split up the circle a little bit, right? And you could even make it, if you wanted to be a little more precise, you could even, once you get a percent, you could take that percent times 360 and figure out how many degrees it is, and then use that to put in your circle. That'd make it a little more precise. So we found the sample size, we add all those up, convert the frequencies to relative frequencies. That's what I was just saying about the percents. Change them all into percents. Could, again, take each one of those, multiply, and if you had a protractor, figure out how many degrees the angle should be each time and draw it in that way if you want to be real precise. We're probably not going to be that precise. So this is what I've done here, change each of those into a decimal. So this one's 24%. So when I go to draw my circle, if that's 24%, well, 24% is real close to what? 25. So it's almost a quarter. So when I go to draw this, and I draw that first one, I'm gonna make it to where it's almost a right angle. And that would be associate's degree. This one here is 51%. Well, that's gonna be that's a little more than half. That's gonna be over here. That's bachelor's. Then we got 20%, 3%, 2% is all we have left. So the 20% is going to be a real major part of what's left here. So maybe something like that much. Probably more than that even, but what's that? Masters. And we got these two. We split them up and they're about the same. That would probably be good enough. We could take a protractor, take each one of these numbers, multiply it by 360, and find exactly how many degrees it are, and start measuring around. I'm not going to ask you to be that precise. You get a job and you got to make pie charts, then you might want to be that precise, but you probably have a computer that would do it for you. That's what I've done here is changed each one into degrees. Then our pie chart would look something like that. Did I go backwards or something? Pareto chart. This might be one you haven't heard of. Pareto chart. Pareto is a guy's name. One of the few things in math. I always say how good mathematicians are because they aren't like scientists. Because they don't just name things after themselves. All scientists, they gotta feel good about themselves giving something their name. Old Pareto wasn't a normal mathematician, I don't guess, because he named this chart after himself. Pareto chart again, qualitative. You're going to have some kind of category down here at the bottom. It might be like freshmen, sophomores, juniors, seniors. The bars, it's an actual bar graph. The bars don't touch each other. The difference between a Pareto chart and just a regular bar graph is a Pareto chart always goes from the highest to the lowest. So the bars always go from tallest to shortest. I'm not sure, never have really been able to figure out what's good about a Pareto chart. I would say that in a business, if I was making up a slide and I wanted to make myself look good for whatever reason, Pareto chart might be okay, but I think we would want to turn it around. Because if I put this, if I'm doing a slideshow for my boss, and I put the bars in there from lowest to highest, and I'm giving this slideshow about whatever it is that's going to help me to get a raise or help me keep my job or whatever, when he sits and looks at that pie or the bar graph that goes from highest to lowest, as soon as you see that, what do you think? On mine, the one I drew. Looks like it's going up, doesn't it? And that's why I don't understand with the Pareto chart why we would ever want to do this, because this makes it look like it's doing what?
You can use it for
Going
like,
down.
amount of people who like smoke and then it goes down over the years.
Maybe that.
So it looks better.
Now the bad thing, again, the bad thing with that, well, and this is where you have to be careful. So my whole point is I think a Pareto chart is sort of cheating. You're sort of trying to make somebody think something that might not necessarily be true. Because if we did that, people who smoke, well, this might be 2016, this is 2015, this is 2017, this might be 2014.
So you can change the order completely on it, just.
The orders, where the order comes from is, it always goes from biggest to smallest in a Pareto chart. So that's why I'm saying it sort of looks like you're, you know, if we were saying, oh yeah, you know, number of people smoking is going down, and we show them that chart, they're probably not even gonna look at the numbers. They're just gonna think it's going down because of that. And if you actually look at it and understand what you're looking at, that's not the case. So that's a Pareto chart, but in a Pareto chart, your frequency's on the side, your categories along the bottom, and it's always gonna have highest to lowest. Biggest bar to smallest bar. Constructing a Pareto chart, create a bar for each category. Bars are often positioned in order, decreasing height. Not often, always for a Pareto chart. I'm not sure why I put often there. And then it looks something like that. So let's see, what did they put on this one? Rates and services, committee, marketing. I guess maybe something like I'm not even sure what this bar graph would be for. I guess if maybe, like let's say here at school where we had to cut positions, cut teachers, and we were trying to figure out, we went back and surveyed past graduates on what they're doing now and related them to each subject area to see which, you know, okay, which teachers can we cut without affecting what's happening out in the community. We might do something like this, so you put them, ones that will be affected the most, all the way down to the lowest, then we could say, okay, those lowest ones are the ones that we need to get rid of. Maybe that's, a Pareto chart would be good for something like that. In a recent year, the retail industry lost $36.5 billion inventory shrinkage. Inventory shrinkage is loss of inventory through breakage, pilferage, shoplifting, and so on. I know I worked at a convenience store, and I know that you guys would never ever do any of this stuff, but every now and then I worked at that convenience store, and they would be bringing in the supplies and stuff that come into the store, and I would have to put them out on the shelves, and I might eat me a candy bar and write it off as it was ripped in the package or something, or it was smashed, so I had to throw it out. So inventory lost by some, whatever happens there. Causes of inventory shrinkage are administrative error, employee theft, shoplifting, vendor fraud, so on and so on. The other thing that might be thrown in here is stuff that gets outdated, which they're probably including that an administrative error, because that would be something like if I ordered 1,000 Snickers and I only needed 200, those other 800 are probably going to go to waste. So if we do that, we put it, go through here, you're going to make a bar for each one of these. Notice the employee theft is the highest, so it goes first. Second one is shoplifting, that goes second. My wife worked down at Kmart in Eaton before it closed, and you wouldn't believe how bad she talked about all you guys and your families and stuff. How people in there just stealing stuff continually, chasing people out. Yeah, so you described that one day. So that's a Pareto chart. Paired data sets. Each entry of one data set corresponds to one entry of a second data set. A paired data set. What's another name for a paired data set? Scatter plot. Scatter plot. Scatter plot. Hopefully you know what a scatter plot is. You got your X and Y, and you just put a scatter plot in there. Sydney's sister's getting ready to have a baby. Once she has the baby, she'll go to the doctor, and that doctor will come out with a little chart, and on that chart, it's got a line on it. And what they've done is they've taken a scatter plot of all the babies over the past however many years and graphed their height and weight compared to each other. And it'll have that line on it, and it'll have 2 X's on it. And the doctor will say your baby, and along the bottom down here, it'll have percentiles. And we'll talk about percentiles later on in the year. They'll say your baby ranks in the 47th percentile of weight and the 67th percentile of height. And they'll keep doing that every time. That's why even when you're as old as you guys are, you go to the doctor, what's the first thing they do? Height and weight. They put you on the scale and measure your height, measure your weight, and they still do that. All right. What that tells them is if the baby's healthy or not. All right. So if you got a baby that's way up here in height and down here in the 20th percentile in weight, there's probably something wrong. The baby's not getting the nutrients it needs. It's not gaining weight like it should. Okay? So that lets them know that. And that's what they did. They used to be, when I had my first son, they actually had a scatter plot and the line drawn through the scatter plot, just dots all over it and stuff. Now it's just a line on the piece of paper, and they put the X's on there wherever your weight and height fall at. Graph used as scatter plot. The order pairs are graphed as points, used to show the relationship between two quantitative. Remember, quantitative means numbers. This would be your line of best fit. That's all they show now, again, is the line of best fit. Later on in the year, we'll talk about how to calculate the line of best fit. We'll probably do it longhand, because it's the funnest thing in the world to calculate line of best fit longhand. I'm being sarcastic. We probably will never ever do it longhand because you won't want to. And when we get to line of best fit, you must have the TI-83 or 84 calculator. Otherwise, you'll have to do it longhand, and you don't want to. We'll talk about most of that stuff later. For now, just knowing what a scatter plot is good enough. On this scatter plot, if we just look at this, don't read this down here. It's got petal length in millimeters, petal width in millimeters. What information could we get from just looking at that scatter plot? Nobody knows anything? Couldn't figure out anything from that?
Got the real short, real fat.
Some of them might be real short, real fat. Why do you think there's a gap here? What do you think that's all about?
They're measuring 2 different things.
What probably happens here, there's a gap here. This group right here, it's probably like some kind of mini flower or something that somebody bred, right? These up here are probably the others, normal flowers. What do you think the normal, if you got an iris at your house, you're some big person who grows flowers really well and you love it, and you got an iris at your house and you go to measure the petals, what would be a normal length and width of the petal?
Maybe like 50 and then 17.
50 by 17. All right, we could figure that out. 50 by 17, 50 would come up in here somewhere. 17 would be over here somewhere, so somewhere about there. That looks like that'd be about the normal size of the petal. But we can figure that out from the scatter plot. Time series. Time series, not hard. Time series, you always have time on the horizontal axis. On the bottom will always be time. And then your vertical axis, your up and down, will be some quantitative number. Might be something like we were talking about a few minutes ago with, we were talking about smoking, and we'd have 2014, 2015, 2016, 2017, and you just have your numbers going up this way, and you'd say, okay, there was this many in 2014, this many in 2015, 2016, it went down to here, 2017, it went back up to there, and you just connect them. So it's sort of like a line graph, but it's always got to have a time on the bottom side. Years, months, days, whatever it is. Hours, minutes, whatever. Some kind of paired data every time. The 2014 goes with whatever that number is. The 2015 goes with whatever that is. We could use a scatter plot on that same thing. Number of screens at drive-in movie theaters. Starting to come back a little bit, but what happened in my mind's old here? If we went on out here, because we're in 2017 now, where do you think this would go in 2001? Keep going down, keep going down. I think it got to somewhere about here, and then it started going back up a little bit, but is it going to go way back up to where it was, way back here? No, it's never going to be up that high again, so it's probably about leveled out now, or last 4 or 5 years, and it's probably going to stay about the same. There's not somebody out there building new drive-in theaters all over the place. But that's a time series. Constructing a time series. Again, we got all these numbers. Table list, numbers of cellular phone subscribers for the years 1998 to 2008. Excuse me. What do you expect is going to happen from 1998 to 2008 with cell phone subscribers? And if we went up to 2017, where we're at now, what do you think would happen? Probably still going up, right? Now, at some point, it's gonna have to level out. So, when we look at this time series, notice how it's going up. If we went way out here somewhere, is it just gonna continue going up and up and up forever and ever? No, something's gonna happen, and it's probably gonna have to level off a little bit, because there's only so many people in the world.
Do you have any issues?
Yeah, somewhere in the fund. I forgot. My friend Dalton Harmon, has to be up every 2 seconds. That's what his nose. So he's used like 2 rolls of toilet paper already this year. Summary, just stem leaf plots, dot plots, preview charts, time series, those are what we covered, nothing really hard. Not sure why page 60 is so big there.
Let's skip to.
On problems 13 through 16, let me look at it real quick. It asks you for like 6 things or something. I just want you to get to. Oh, no. The directions on 13 through 16 say, give 3 conclusions that can be drawn from the graph. So instead of giving 3, I just said give 2. On problems 35 through 38, says a misleading graph is a statistical graph that is not drawn appropriately. This type of graph can misrepresent data and lead to false conclusions. Explain why the following graphs are misleading. Redraw the graph so it's not misleading. All I want you to do is explain why they're misleading on those. Don't redraw the graph. What kind of card did you get, Jake?
It's overheated.
Huh?
Already overheated.
It's overheated. Yeah, see a lot.
There's a, I'm reading the radiator. What's the radiator? Many said they know, design it. It's like colors.
So it's,
You haven't paused the time yet.
sorry.
The time hasn't been paused.
Are you gonna say something else?
Ned's and everyone's moving around.
I was waiting on Sophie to say something dumb so I can catch it on it. Record it.
And